Here we go. We're recording. Perfect. Okay. I'll start by reading the intro. In the past few lessons, you have determined how to move the graphs of parabola around, that is to transform them on a set of axes. You've also learned how to write quadratic equations in graphing and in standard form. In this lesson, you'll put these new skills to work as you use parabolas and their equations to model situations. So it's basically a lot of word problems. That's what we're doing today, a lot of word problems. So when you see modeling, that's what it really means. It means that you're taking a real life situation and you're using an equation to understand that situation. That's what it means. So just in more layman's term, modeling means taking a real life situation and using a math equation to make sense of that situation. That's what modeling ever is. Give you a great example. I know the boys are going to love this. So fantasy football, I know you guys, I hear you guys talk about football all the time. So I actually developed statistical models to predict outcomes for quarterbacks, running backs, and defenses. More than happy to show it to you guys when I have a chance. It actually uses a lot of like in-season data, like first down percentage, completion percentage, the point spread, the point totals. So these are the kind of things that I developed over the years that, for the most part, are somewhat accurate, but we'll see how this season goes. But that's a model, right? Because I took a real life situation, which is NFL football, you watch on Sundays or Monday night or Thursday night, and use math to make sense of it, right? Like, okay, so this situation is going to happen. Who's going to play well, right? And why does that matter to me? Because it means I make more money, right? Because I beat somebody, I win the league, right? So that's my motivation. So I'm internally motivated by the money, right? No, but or just to brag about that, I'd be the other person. But that's what modeling ever is. It's just taking a real life situation and using math to make sense of it, right? And more specifically, using a math equation. For this case, we're going to use parabolas or quadratic equations. So let's look at this one right here. So who should I have? Jack, do you mind reading the part about jumping jackrabbits, please?
The diagram of the jackrabbit just clear the fence for evidence for this government. Sketch the situation, write the equation.
Okay. No, you got it. Thank you. So yeah, so there's some information to tell us here. How high does the jackrabbit jump? So it gets to a maximum height of 3 feet totally, right? And they say it starts 4 feet from the fence. So here's what I'm going to do. I'm going to draw a coordinate plane like this. I'm going to let this be X and let this be Y. And let me erase the other stuff so it's not distracting. Okay, there we go. So clearly I put the origin. Where did I put the origin in reference to the diagram? Where's the origin located? In reference to this real life situation.
0, 0. But is it where the rabbit jumps, start jumping, or is it in the middle? Yeah, I put it in the middle. I put it where the fence is actually. So see how the fence is at 0, 0? I deliberately put it there to make the map easy.
Now, if you think about it, let's label these points here. Give me the coordinates of each of those points.
-4, 0.
Good.
4, 0.
Perfect. Thank you, Jack. Does that make sense? How I got those?
Right? Because obviously it hits a height of 3, so it should do 0, 3, right? And I put the y-axis at the fence. I didn't put the y-axis like 10 feet away from the fence. That's crazy. I didn't put the y-axis 20 feet away from the fence. That's crazy. I put it right at the fence, so to have nice symmetry, right? Make the math easy for yourself. You get to choose how you want to model it. You can make it hard for yourself or make it easy. Make it easy. So 0, 3 is where the height of the maximum height of the rabbit, and then -4, 0 is where it starts. Where does it end? 4, 0. Good. So there we go. So we have start, high point, and end. Very simple, right? Should not be that hard. But you gotta model it correctly to make sense of it. So we start -4, 0, get a high point of 0, 3, and at 4, 0. Okay. So how can we make it fit the situation? Boom, just did it. Just did it for you guys. How do we make a graph? So really, what you should do is put the y-axis where the fence is located. Right? Very, very simple. Put the y-axis where the fence is located.
What information do we need in order to find an equation? We need a vertex and another point. How can we be sure that our equation fits the situation? We could plug the points back into the equation. So that's what happens there. So let's actually come up with the equation. We're going to do that in just a second. I'll give you guys a chance to copy that stuff down. So again, how do we make a fit situation? Put the y-axis at the fence. What information do we need? At the vertex and at the point. In this case, I have 2 extra points in addition to the vertex. And how do I know I have the right equation? Plug the points back in, see if it fits. Okay, so we're cool. Can I erase? Okay, erase. Let's erase. All right, so let's do it. So let's make the equation. So y equals a x minus h squared plus k. That's going to be probably the best equation to use, or the best form to use, because duh, we have the vertex, right? What's my vertex again? 0, 3. And what letters in this formula represent the vertex? H and K, totally. So H is 0 and K is 3. So y equals a x squared plus 3. And you probably don't need the parentheses. Let me get rid of the parentheses, because obviously it's just x squared. How do I solve a? What would I do to solve a? I have an extra point, right? Give me the coordinates of one of my extra points. Remember, the graph was like this, right? Yeah, or 4, 0. Let's plug that in. And solve for a. So 0 equals 16a plus 3. Work it out. You should get negative 3/16, I think. So what's your final equation? Y equals negative 3/16 x squared plus 3. And if I were to plug in
0 for x and 3 for y, it would work. If I plug in 4 for x and 0 for y, it would work. Plug in negative 4 for x and 0 for y, it still works. So if I'm plugging in all 3 of the points that I plotted according to the real life situation for the rabbit, plug an equation, it's going to make sense.
So without actually telling you explicitly, hey, here's the vertex, here are the x-intercepts, if you just model it correctly, you can easily come up with the equation. It's not hard. Some people get really freaked out when they see these problems because they're not trained to think how to model, right? I think this is one of the most important skills to have when it comes to this class. Like, you got to be able to take the math and apply it to a real life situation, right? That's when the math becomes relevant. That's when you actually feel like you're learning, right? Or especially for those who are doing PSAT or any standardized testing down the road. Well, the harder questions, as coaches do get harder on these tests, usually involve modeling. And that's where students usually struggle because they don't get enough training with it. So I want to make sure you guys are well trained. Questions on this? No? Okay, I'll get my soapbox. Let's do another problem. Okay, let's keep moving. All right, let's look at the next situation here. Okay, so when Ms. Wong kicked a soccer ball, it traveled horizontally 150 feet and reached a height of 100 feet as highest point. Sketch a path, blah, 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 come up with the equation. Okay, I'll do the sketch. I'll have you guys come up with the equation. I'll walk around and see, make sure you're getting it. So let's do the coordinate plane, right? So here's Ms. Wong. I'll do a little stick figure. Okay, here is a soccer ball. She kicks the ball. It lands right here, right? So this is where she starts. This is where it ends. And that's a high point. Okay, guys, give me the coordinates. What would be the coordinates here, here, and here? So fire away. What do you think the coordinates are for each of those 3 points? Given the information you're just told. Given all that info. What's a high point, guys? 0, 100. What's the starting point? What's the coordinates for the starting point? Excellent. Thank you, Matsu. Was that you, Matsu? Or thank you. Well, thank you over there. Okay. And then what's the ending point? Perfect. And the general formula will be this, right? Okay, have at it. Make the equation, check with your table mates. Should be really simple to write. And then we'll move on to the next page. Let me know if someone has an answer they want to share. You might need a calculator. Yeah, good. Make it quick. You're going to calculator out. You need a. Oh, Ben, good, good. Yeah, go ahead. Yeah, totally. Hopefully, I have this so far. And then plug in 75 for x and 0 for y. You guys get negative 100 over 5625? Negative 150? It's 100. The y coordinate of the vertex is 100. So you should get a weird decimal for A. Anyone want to share what they get? What they got? But what decimal when you negative 0.017? Yeah, I like that. Good. Yeah, we'll do like 4 decimal places. So the final answer will be this. I'll put up top in dark blue. Y equals negative 0.0178 x squared plus 100. So now why would this matter? I mean, fine, great. You're picking a soccer ball, whoop-de-doo, like, well, what if the goalkeeper or the goal's over here, so you want to make sure you can get over the crossbar, you get under the crossbar. If it goes over the crossbar, then it's out of bounds, right? Yeah, a goal gets it, it's taking it aside. So sometimes you want to make sure that you're angling your kick the right way, right? So it does. I mean, of course, a lot of things can happen, like the defending can get in the way, the goalie can like reach the pocket. I mean, there's a lot of other, there could be the wind, the weather, but anyway, sometimes it matters because you want to make sure that you're like where baseball has clear fence, right? If you or field goals, right? I think one guy in the Jets missed a 50-some-yard field goal last night. Didn't hit the crossbar? That I think it was Greg Zerline. So yeah. Anyway, all those things kind of matter. Like, you want to make sure you have enough distance to get what you need to do. Mm-hmm. Yeah, so I subtracted by 100 and divided by 75 squared. Yeah, so I skipped a few steps. I'll show you exactly what I did. So I plugged in, so I subtract both sides by 100. So I had A times 5625, and then I divide by 5625 to get that. Yep, no problem. Okay, we're cool on 65. All right, let's move on to page 2. All right. Page 2, here we go. Okay, at the skateboard park, the hot new attraction is a U-dip, a cement structure embedded in the ground. So you guys know how skate parks work, right? I mean, there's one like by Burgess Park, Menlo Park, right? The cross-sectional view of the U-dip is a parabola that dips 15 feet below the ground. The width at the ground level is its widest part. It's 40 feet across. Sketch a cross-section view of the U-dip and find the equation of the parabola that models it. Okay, so let me do the drawing for you guys again. So let's say this is ground level. This is the ground. Hold on, let me write more nicely. This is ground level. And then the ramp goes like this, right? Again, ground level's right here. How wide is this thing again? How wide, guys? 40 feet. Sorry, it should be just this symbol means 40 feet. And how deep does it go again? 15 feet. So what I would probably do is draw a coordinate plane like this, X and Y. What are the coordinates of all my points here? What's the coordinates of my vertex? I made it pretty easy. 0, 0. If you can make it 0, 0, that's nice, right? What are the coordinates of the other 2 points at the ground level? What would you say the other 2 points? What would those coordinates be? Sorry, repeat that again. Well, but it's going to be higher than 0 now. Because I made the origin 0. Yeah, I say 2015. Now, if you wanted to make the ground 0 for y, and then the vertex be 0, -15, you could have done that too. But I think it's easier just to let the vertex be 0, 0. Okay, make the equation, guys. Let's go. Make the equation, tell what you get. So again, general formula, y equals a x minus h squared plus k.
Okay, so here's ground level. Then you get your skateboard, go down the red ramp, come back up, select ground level. 40 feet wide, 50 feet deep into the ground. But I made the low point 0, 0. Again, you can make the vertex any coordinate you want. I don't care. But why make it not 0 if you can't? But then the other points are in relation to it, right? They're related, right? That's 2015. That's maybe 2015. Of course, it makes sense.
So if your vertex is 0, 0, you should have just y equals ax squared, right? How do you solve for a? What do you do? Or someone want to tell me what to get for a? Excellent. That is correct. Thank you, Jack. So when you solve for a, I'll do it over here in purple. 15. That's not going to work. 15 equals a times 20 squared. 400a equals 15. It's opening up, so it's a positive value. 15 over 400 is your a value. Or you can say a is 0.0375. Okay, we're cool. So the answer is going to be y equals 0.0375x squared. So again, pretty standard. It's not that hard. But notice the drawing helps. Once you get good with it, you can do it without a drawing. You could just see in your head. But I think you got to draw. You got to draw. Now, fortunately, drawing was done for you for the next one. Let me read it, and I'll kind of have you guys just do it. So to give you a general formula, the height of a path of a falling object can be modeled by the following equation. By the way, this is acceleration due to gravity, in case you guys are curious. Because why do things fall? Gravity, right? That's all physics. So in case you're curious, that's acceleration due to gravity. So it's not really that important. So you guys know that. I just wanted to share that. H is the height. T is time. V sub 0 is initial velocity. H sub 0 is initial height. So you're told the initial speed is 3. So that's V sub 0. You're told that you jump off. Sorry, he jumps off a footbridge. Okay, hopefully it's okay. 30 feet above the lake. A little dangerous, but that's okay. So the equation I'd write like this then. Y equals, let's change H to Y. Let's change T to X. Okay. So how long will it take them to reach the water?
Thoughts on what we should do? How would you solve the question? Definitely factor good, but why are we factor? So what's why? What do I set equal? So what does y represent again? let's back a little bit for the height. What is the height? So I replace h with y.
Height of the object that's consistent.
So why is the height of the object? And let me be a little more explicit about that. Why is the height of the object?
Y represents the height of the falling object off the lake or from so before he jumps, what's his height from the lake before he jumps? How high is he off the lake before he jumps? 30 feet. When he hits the lake, what's his height now? 0. Exactly. That is huge. So when he hits the lake, so this is very important, guys. This is why people struggle with these problems. When Finn finally hits the lake, his height from the lake is 0. That means y equals 0. Now solve for x. That's what you got to do. That's where people struggle, is that they don't know what these letters represent and they get stuck. You have to, and I'll be very clear. I'll tell you, hey, why is this? But you have to interpret it correctly. That's your job. Okay. So here's what we're going to do. You're going to set this equation equal to 0 because that's the height off the lake. And we're going to do some factoring. Or maybe we have to do something else. Maybe we can't factor. So I don't know if we can factor it. I don't know if this is factorable, guys. I don't think it is. Yeah, I can't think of. I'm going to cheat because I have a program in my calculator that does this. Let's see, I'm doing quad 4 on my calculator. Okay, so we can't factor it. It's not factorable. So what can we do instead to solve it? What do you guys think? You can do quad form, or I'm okay with this too. If I'll have to talk to the teachers about it, but you could also go to Desmos. You can graph it in the calculator. So it's not factorable. So you have a few options. So let me erase the other stuff here. Oh, come on. So let me erase the other stuff here really quickly. It's not factorable. So you could do this. There's a few options to solve. Here are your options. Let me get my stylus out. It'll be easier. Here are options. You can use quadratic formula, which is kind of a pain, but you can. You could complete the square, which is also kind of nasty, but you could do that. Or you can graph in Desmos or TI-84 calculator. By the way, for those who are doing the PSAT in a couple weeks, actually next week, sorry, Desmos is built in to the SAT, into the app. So if you have something like this, just pull the Desmo app and just punch it in. It's now part of the SAT. So that's what I'm gonna do. I'm gonna use Desmos. So let's do it right now. So let's go Desmos. Y equals negative 16x raised to the second power plus 3x plus 40, no, plus 30. Okay, great. Here's my parabola, right? So what am I looking for here? Where has the x-axis? So hits this x-axis. So I'm looking for x-intercepts. One of them is negative. That makes no sense. That's your answer, guys. 1.466. So it takes them 1.466 seconds to hit the water, which kind of makes sense. If you jump off a bridge and well, we hope it's not too high and you can swim. Maybe you're in Yosemite or somewhere in the national park where you do this. Takes a little less than 2 seconds to hit the water. So that's what I would do. Just make it easy for yourself. And you can do this in your homework, by the way. I'm totally fine with that if you're doing your homework this way. So a few options to solve. Those are your few options. Any questions? All right. So here's what I have you guys do next. I'm gonna have you guys work in groups on the next problem. I'll come and help you guys out. I'll pause the video. All right. So you're gonna be investigating a function. Now, just so you know, this is not a parabola. Okay, guys, quiet, please. Thank you. So this is not a parabola. This is a new function for you guys. A new type of function. 1 over x is called a rational function, by the way. So what I want you to do is graph in Desmos. So hopefully someone has a laptop or a calculator, I don't care. And go through these questions here. I'll walk around and help you guys out. So yeah, that's what we'll do. So let's work on this page. I'll share the answers in a few minutes, and then you guys get a head start on homework. So let me pause video. Okay, so again, the answer for part A was all real except 0. For part B, basically y gets closer to 0 when x gets bigger or gets smaller. For part C, I chose those numbers are close to 0. And if you were to plug those into the equation, you should get 10, 100, or 1000. So basically, y just increases really fast as x gets closer and closer to 0. So if I were to do a plot, for a plot the points here for y equals 1 over x, right? So you have 1, 1, -1, -1. If I plug 1 half, I get 2. If I plug in 2, I get half. So the graph kind of looks like this. Or if I plug in -half, I get -2. Or plug in -2, I get -half. So if you think about it, the asymptotes are basically boundaries. Okay, that's hard to read. Sorry about that. I don't know why I go with purple. Here we go. The asymptotes are boundaries for your graph. So let's think about it. So you have a horizontal asymptote and you have a vertical asymptote. This is part F, by the way. It's all part F in blue. So what would you say the equation would be for the horizontal asymptote? If it's just the x-axis, what equation would you give that? If it's just passing, if it's just the x-axis, what's the y value when you're on the x-axis? Good, y equals 0, exactly. The vertical asymptote, you're now on the y-axis. What's true about all the x values when you're on the y-axis? X equals 0, right? So that's part F, guys, in light blue. So those are boundaries, because look at the graph, right?
It's getting really close to 0 for y. When x goes forever to the right, it's flat. When x is really close to the origin, it's going up or down forever. So it's looking kind of vertical, right? It's shooting up pretty quick. I mean, Desmos shows the guy when you take it. So those are called asymptotes.
I know you guys not gonna remember this. I feel like I need to say it because I've taught calculus and I'm gonna repeat it often, don't worry. But we actually call this an infinite discontinuity. I want to start using that term often because you'll need to know that when you take calculus down the road. This right here is called the end behavior asymptote. Why did it get these names? To get these names because
there's clearly infinite nature to the graph. The graph's not continuous. You have to lift your pen and pencil off the paper to keep drawing the curve. There's a break in the graph at x equals 0. That's what we call this constant infinite nature to it. Y is going towards the plane or Y is going towards the plane. And behavior, you look at the ends of the graph, the left hand and the right hand, how does it behave? They behave like Y conservatives. The ends of the graph look like Y because they look like horizontal.
So that's what's happening with that. But again, this is all new stuff. I'll keep feeding this into you guys over and over again. Lastly, the range. Because I don't want to move my screen, I'll do part G over here. So again, all this is part F that I just did right now. So this is ENF, just so you know. Part G, the range. Are all Y values included, or there's a Y value that's left out? So let's look at both branches,
right? This goes from negative infinity up to what Y value? Get closer to what Y value is curve this way. Y is getting closer to 0, right? Up here, Y is a positive infinity, right? As you come back down, this Y getting closer to is 0 part of our range now? No, it's not.
So you're gonna say all real numbers except 0. Now, things will change. We're gonna start moving this around a little bit.
You can think of this, anyone play those Call of Duty or those shooting games? That sounds, I shouldn't count as a school, but it's kind of like a crosshair. You have to do the crosshair around the game if you're. So anyway, don't mind me saying that stuff.
So it's all real numbers except 0. But we're gonna move it around. We will move it around eventually. So okay. So I'm all done. We got about 13 minutes before lunch starts. Homework, you get a head start if you want. If you need a little brain break, you got stuff to do for the class that's more pressing, that's fine. I'm totally cool with that. I'll let you guys down in about 10-ish minutes. Okay.
What?
I'll let you guys down in about 10-ish minutes. Because I see that lunch line is pretty crazy for you guys.